Good day. We are moving on to look at projectile motion, which is motion in one dimension. Consider an object moving up and coming down, or being thrown down. That is a projectile motion. Just before I get into further details, I'm referring you to our Revolutionary Science Workbook Study Guide 1, written by Norman Muvoti and Timothy Sibeko, with the ISBN number that's on your screen right now. Please make reference to it for more information. Just a few quick definitions before we look at projectile motion. What really is a projectile? A projectile is simply an object upon which the only force acting on it is the force of gravity. A free fall is defined as when a force of gravity acts on an object. When only the force of gravity is acting on an object, that in itself is a free fall. So in this situation, there is air resistance, so it might not be really a free fall. Neither does it describe a projectile. But as we get into our lesson today of understanding projectile motion, let's remember that when we refer to projectile motion, the only force acting on an object is the force of gravity. We use equations of motion to determine position of an object, the velocity of an object, the displacement of an object, displacement, which is a vector quantity of distance with direction, of a projectile of any or object at any given time. You must be familiar with these equations. Vf is equal to Vi plus A times change in t, and delta x or delta y being equal to Vi times change in t plus half A times change in t. What's important for you to remember is that amongst some of these values are vectors like V initial and V final, as well as acceleration. So we have to have a direction before we write out the figures or the values of those parts of the equation. As for time, I'm sure you'd understand it's the only scalar quantity within our equations of motion. For us to understand better, I'm going to look at graphs of projectile motion. Imagine an object. This is a position time graph that moves from a position 0 and gets to its highest points, where at its highest points it's got the final velocity of 0, which can be an initial velocity coming downwards of 0, and then it falls, all right? Throughout the motion of the objects, there is a force that is acting on an object, and that force is, yes, the force of gravity with an acceleration of 9.8 meters per second squared. Now, as you can see, there is a symmetry of time. The time it takes to reach its highest point is equal to the time it takes from the highest point back to the point of origin. In other words, twice the time is the total time. Twice the time it takes to get to the highest point is the total time to get back to its original point. All right, now that you have understood this part, let's move on to the velocity time graph. If I have chosen in this instance, like what I have done, the upward motion as being positive, the velocity of the object is going to increase as the object goes up, and the velocity of the object is going to decrease, as the object goes up until it becomes 0 at this point. And after that, due to gravity, the object starts increasing in velocity. If it's going back to its original position, all right, it will have an equal v being equal to minus v, only difference in direction. In this case, as I have said, I have chosen upwards to be positive. The gradient of this graph is a negative gradient. Gradient of a velocity time graph gives me the gravitational force, 9,8. It is in the negative because I have chosen upwards to be positive. As for the area of the velocity time graph, it is going to give me the distance covered. So keep that in mind as we look through questions that are to do with the projectile motion. We have represented vertical projectile motion in words. I've explained the time symmetry involved, all right, and that there is a constant acceleration due to gravity. That does not change whether an object is going up or coming down. I've given a position time graph, a velocity time graph, an acceleration time graph for our free body, free-falling object, which is a projectile. Let's go straight into questions on projectile motion. An object is projected vertically upwards. So upwards it goes. Ignore air resistance, right? As the object rises, its velocity what do we know? As an object rises, we know that its velocity decreases, its acceleration is constant. It is the same, the acceleration due to gravity, and the acceleration is always acceleration due to gravity, and it's working downwards. So which one is our answer there? Look at the question once again, think about it, and consider it for your answer for the question. Yes. Did you say the answer is C? If you say the answer is C, that's correct. The velocity is directed upwards, but its acceleration is directed downwards. Let's look at another question. Here is a question that says, the top part is not that clear, so let me read it off. The left top. it says that a stone A is projected vertically upwards at a speed 12 meters per second. So there is stone A being projected upwards at a speed 12 meters per second, and from a height of h, right, above the ground. Ignore the effects of friction. The question then asks us to calculate the time taken to reach the maximum height. So let's look at 3.1 together quickly. 3.1, calculation of the time that it takes to reach the maximum height. What do we know in this question? One thing that we have to do is to choose direction. If I choose upwards to be positive, which means that my initial velocity is going to be 12 meters per second, positive, right? And if it is 12 meters per second, my final velocity is 0, because at the highest points, the object is going to have a final velocity of 0. My acceleration due to gravity will have a negative 9.8 meters per second, right? So I can have one equation of motion amongst the equations of motions that I have on my list that can help me to calculate, the value of the time. We can use the first equation because I've got V final, I've got V initial, I've got acceleration. Therefore, I can find my change in time. All right, let's look at it. V final is equal to V initial plus acceleration times change in time. Okay? V final is 0, V initial is 12 plus, why is my acceleration negative? Because I have chosen the upwards to be positive. Acceleration is always working downwards, and if downwards is negative, my acceleration is a negative 9.8 meters times change in t. If I calculate my change in t, solving this equation, I should get a value of 1.22 seconds as the time taken. Now, with these questions that are to do with equations of motion, projectile motion, remember there are different 4 equations that we can choose from. Sometimes it's not only one equation that's applicable in answering this question. And again, some people can choose downwards to be positive, meaning that their VI is going to be equal to minus 12 meters per second, and V final 0, and acceleration will be positive 9.8 meters per second squared. All right? In this instance, once again, substituting into Vf equal to Vi plus A times change in t, they will come up with the same answer, change in t equal to 1.22. You can try it, you will still come up with the same answer. There are other ways that you can do it also. longer routes that you can use to find the same answer. For instance, you can consider the equation Vf squared is equal to Vi squared plus acceleration multiplied by 2 multiplied by change in y in this instance, okay? In this instance, one thing that one might want to find is the change in y first, then use the change in y to find change in t. That you can also do. Find the change in y, and after you find the change in y, you can use the equation on change in y equal to v final plus v initial over 2 multiplied by change in t to find the value of change in t. I assure you, using the two equations, you will come up with the same answer. Change in t is equal to 1,22. Try it on your own for practice, and you will see that we come up with the same answer. What I'm interested in is another different method right now, in which I apply something that we have already done, okay? Which is F net multiplied by change in t is equal to change in momentum. In other words, the mass multiplied by g times change in t is equal to mass times v final minus v initial. Okay? The masses will cancel. All right? If I'm choosing my upwards to be positive, my downwards is negative 9,8 multiplied by change in t is equal to v initial. My v initial from v final will be 0 minus 12. Guess what? Your change in t will be still 1,2 seconds. So I have used impulse in order to calculate the change in t in a question that is to do with projectile motion. Well, question 3.3 says, at the instant that A passes its initial position. So at the instant that A passes its initial position, that is on its way down, stone B hits the ground. So stone B is hitting the ground at the same instance that stone A passes its initial position. Stone B hits the ground. The question now says, calculate the value of h. So what we are looking for is calculating the value of h. How are we going to do it? Finding the value of h. We are looking for the height of h. At the same time, 3.3. All right, what information do we know? Look at the question. At the instance that stone A passes its position on its way down. Stone B hits the ground. The simple way to calculate this is to think of it this way, by considering the fact that if we have V final being equal to V initial plus acceleration times change in t, right? That being the initial velocity, okay? If we multiply minus 3v, right, being equal to minus v plus acceleration of minus 9,8 times 1,22, which is the time taken, we would find that the value of v is equal to 5,98 meters per second. Right? If the height is 5,88 meters per second, we now have the final velocity. This question is asking us to calculate the speed v with which the stone B is thrown towards the ground. What is common at the point where V is being thrown towards the ground is the time. We know that it's at the time 122, right, that the stone B, 1.22, that the stone B is thrown to the ground. So that is how we are coming up with this 1.33. The speed of 3v final is minus 3v because I am choosing my downwards to be negative. So therefore, the v initial of that thrown on its stone on its way down is equal to minus 5,98 meters per second. All right? So the question is saying calculate the speed. If it is speed, therefore the speed is a vector, is 5,98 meters per second. All right, 3.3. We had left out 3.2. So 3.3 says calculate the height h. Now, for us to find the height h, we are looking for delta y. Delta y is equal to vi multiplied by change in t plus half of acceleration times change in t squared. We know that the same time that it takes for B to move from where it is to the ground is the same time that it takes for A to move from its point of origin back to its point of origin. So therefore, change in y is equal to our initial velocity, if I am choosing downwards to be negative, minus 5,98 times the change in time, 1,22, plus half times acceleration negative 9,8 times change in time 1,22 all squared. My final answer should give me a height that's approximately equal to 43,76 meters. Okay? The answer there will be negative, but because it's a height, all right, we put our height as a positive number because height is a scalar quantity. This was the value of delta H. All right, next part then says, sketch velocity time graph for the complete motions of the stone A and B on the same axis. Label your graphs for stone A and B clearly and show the following on the graphs. Time taken for stone A to reach its maximum height, and also the velocity with which stone B is thrown towards the ground. So graphs are very important in representing information. How would we come up with this graph? We know that at the instance that A is projected upward, stone B is thrown down. Okay? So, while A is moving up, B is moving down. And at the same time that A gets back to its point of origin, B hits the ground. So let's look at the graph that represents that. The common time is 1.22 seconds. So, at a time of 1.22 seconds, right, stone A is reaching its maximum height, and twice that amount it reaches its original point and continues to fall further down. So there is a graph that's representing stone A, and here is the one that's representing stone B, all right, of the different velocities of the object. At this point, the object has reached, stone A has reached its maximum. Here it has reached its maximum. Here it has reached back its point of origin. All right? That shows the graph that the initial velocity and the movement of stone B. All right. I think that graph should be clear on showing the two different graphs. Right. Let's move on to another different graph that's showing if the upward is considered negative and downwards is positive. Right? That's how the graph should be looking like for the second tag. All right. Another question, November 2015, of a projectile. Let's look at the question quickly. Ball A is projected vertically upwards at 16 meters per second from the ground. Ignore air resistance. Use the ground as the reference point, 0. Okay, calculate the time taken by the ball A to return to the ground. So for 3.1, we have got ball A. If I take upwards to be positive, so it's projected upwards, V initial is equal to 16 meters per second, all right? And if it comes back again to its point of origin, let's call it V final, it will have a velocity of minus 16 meters per second. The constant acceleration is equal to minus 9.8 meters per second squared. And they want us to find the time it takes to reach its final velocity. Once again, we can simply calculate it by using V final is equal to V initial plus acceleration times change in time, of which V final here is minus 16 is equal to V initial 16 plus minus 9.8 times the change in time. All right. Why negative? Because I've chosen negative to be downwards to be negative and upwards to be positive. Therefore, the value of delta t, if you calculate it properly, should be equal to 3.27 seconds. All right. Someone else can choose another different parameter where V initial, they take the movement of the projectile up to the highest point, where the V final is the highest point. All right? So V initial will be 16. We are still, in this instance, taking upwards to be positive. And V final equal to 0. And acceleration being minus 9.8 meters per second squared. For this instance, we are saying V final is equal to V initial plus acceleration times change in t. V initial 16 is equal to 0 plus 9.8 negative 9.8 times change in t. Okay? For this particular example, one can find out that the change in t will be 3.27 over 2. All right? So that shows the time symmetry. Okay? To get the time it takes to hit the ground, obviously you would need to total time multiply by 2, which gives you again 3.27 seconds, just like we found on the previous one. The next question says, sketch a velocity time graph of the ball A, showing the following initial velocity, time taken to reach the highest point, and the time it takes to hit the ground. Once again, if I take the upwards to be positive, in my examples here, you can choose otherwise. It means that the initial velocity is 16, all right, halfway through. Okay, and the time it takes to reach halfway through will be 3.27 over 2, and this is 3.27, all right, and 16 and minus 16. I've got a better graph on the board that illustrates that. Okay, 1.63 highest points and 16 meters per second downwards, and 16 meters per second upwards. All right, so that's projectile motion using the equations of motion and calculating those values. Consider those, think about them, work through them, practice, practice, practice. We'll see you once again in the next session where we continue with projectile motion. Ciao from Chibs. Let's go for